Welcome back to m253 Calculus 3, and in this video we're going to take a look at section 3.2. After defining some ideas behind the vector valued functions, we're going to do some calculus on them. First, the derivative. We're going to define the derivative in a standard derivative way that we did back in Calculus 1. But without going too deep into this, we're simply going to use our derivative laws, our derivative shortcuts, if you want to call them that way, and apply it component by component. After we do some derivatives, we're going to see the idea of a tangent vector is really a way to connect these derivatives with the geometry of a space curve. In 2 dimensions, in a plane curve, we can see that if we go to the point on the curve by putting in a value, in this case, if we put pi over 6 in there, and take the derivative of the vector valued function and put pi over 6 there, we'll see that we will get a vector that is actually tangent to the curve. After studying some tangent vectors, we're going to define the idea of a unit tangent vector. Sometimes called the principal unit tangent vector. And these vectors will allow us to begin the study of applying a frame at each point on a particular curve. Again, this is our example of the helix. A helix is pretty circular, going around in the XY plane, but the Z component would have you go up. And so this is, again, a common curve and a very nice curve to study when we're looking at the unit tangent vectors. After that, the other part of the calculus that we're going to study are integrals. We can apply the definite or indefinite integral to a vector valued function, and as we see here, we are simply going to integrate component-wise. Whether we do it in 2 dimensions or 3 dimensions, our integral is going to be the same old integral that we've been doing before. This will be useful for us when we study motions in space, when we have an acceleration like the gravity and we want to eventually find the position. We will have to apply a couple of integrals, a couple of indefinite integrals, and get to the position function. Okay, that is our rundown of section 3.2. Good luck.